Atoms have very tiny masses. The mass of one atom is on the order of 10 to the minus 24 grams. It's really, really small. And such small numbers are a pain to deal with. And so scientists made a unit to avoid using such really, really small numbers. And you know, it's like, well, that's kind of a cop-out. You just made up a unit. Yeah, but all the units are made up, right? All units are man-made. We just decided how long a foot was and how long a centimeter was. And we make up these units so that they're convenient. That's why the metric system has different prefixes to change the size, so that you don't measure the distance between Reedley and Fresno in centimeters, you measure it in kilometers, because you end up with more reasonable numbers. So we created a unit called the AMU. So the abbreviation is AMU, and we say AMU, not AMU. It sounds like, you know, maybe a cousin of an emu or something. And that stands for atomic mass unit. It's a unit for measuring the mass of atoms. So one atomic mass unit is equal to 1.66 times 10 to the minus 24. And we're not going to use that much, but that just shows you how crazy small this mass unit is. And so what we do for elements is we look at the average atomic mass. Because remember, we talked about isotopes and how they have different numbers of neutrons. The neutrons have an atomic mass of approximately 1 atomic mass unit, and the protons are approximately 1 atomic mass unit. So if you throw in an extra neutron or two, it changes the mass of the atom. Well, we don't deal with atoms individually, we deal with large numbers of atoms. And so what we do is we deal with the average mass, just like we talked about the average mass of the jelly bean. We're not looking at individual jelly beans, we're looking at a whole bag full of jelly beans. So the average mass for an element is the weighted average of the masses of all the isotopes of that element. So for carbon, the average atomic mass of carbon is 12.01 AMUs. And we find that number on the periodic table. Here's carbon. Under the elements on the periodic table are numbers, and those are average atomic masses of the atoms in atomic mass units. That's the average atomic mass. There is actually no carbon atom that actually weighs 12.01 atomic mass units. Just like, you know, we talk about people being, you know, well, what's normal? Well, is any one person normal? Probably not. We're all a little strange, one way or the other. But there's this average, this medium in the middle that we think of as normal, even though nobody actually hits it. But even though there are no actual atoms that weigh 12.01, the average is 12.01, and that's what we care about. And that enables us to count atoms of carbon by weighing a sample of carbon. So here's an example. What would the mass be of 431 atoms of carbon? Well, we know that the average mass is 12.01, the average mass of one carbon atom. So this is just like finding, doing a problem with marbles. So here's the number of marbles, the number of atoms. Here's the average mass of one marble, one atom, and we can figure out how much the whole group of marbles weighs. So here's an exercise. Calculate the mass in atomic mass units of 75 atoms of aluminum. The atomic mass of aluminum is 26.98 atomic mass units. They're giving it to us in this problem, but it's also on the periodic table. So what we would do is we would take the number of atoms, 75 atoms of aluminum, and we're going to multiply by the mass of one atom. and it's 26.98. So 26.98 times 75 atoms gives us a mass of 2,023.5 atomic mass units. Now, if we were going to think about significant figures, 75 atoms, that's a counting number. 26.98 has 4 significant figures, and so we might want to round this to 2,024 atomic mass units. But this is the sort of math that we do in everyday life. You know, if you're mailing books to a friend or something, and each book weighs 2 pounds and there's 5 books, how much does the package weigh? 10. 5 books times 2 pounds for each book. That's what we're doing here. It's just with atoms and this funny unit, atomic mass units.